This video will cover section 7.1, which is systems of linear equations and two variables. Chapter 7 in general is going to cover systems of equations. And section 7.2, we're going to cover systems of linear equations, but in three variables. And because we're talking about three variables, we're going to have three equations. We're going to skip 7.3 because it's not part of the curriculum, but 7.4 will be also systems of nonlinear. So we will be doing like a quadratic equation with the equation of a circle, and then how many points does it intersect at. It is actually pretty easy, 7.4. So 7.1 is something that you guys have been seeing since Algebra 1, I believe. Algebra 1, Algebra 2, even geometry, you see systems. And so systems, sometimes, if they're linear, we're going to talk about two lines, and like you can see here, if you do have an intersection point, then you say that the system has a solution. And since it is a point, it's going to be represented by the coordinates. So in this case, I believe that is a 6, 3, 5, 3.5, something like that, right? We're just estimating. So in this case, we're going to have a solution for x and also a solution for y. So I'm going to read the slide. Researchers identify college students who generally were procrastinators or non-procrastinators. The students were asked to report throughout the semester how many symptoms of physical illness they had experienced. You can see that on figure 7.1, the graph. It shows that by late in the semester, all students experience increases in symptoms. Early in the semester, procrastinators reported fewer symptoms. So what color is the graph that represents the procrastinators? The red procrastinators, correct. So if you guys notice, at the beginning of the semester at time 0, here, 0 weeks, the procrastinators, they had less symptoms, right? What are this? Number of symptoms of stress, right? And where were we? But late in the semester, as work came due, they reported more symptoms. So you could see that for the red graph, we started so low, but it ended much higher than the other, right? What do you guys think procrastinators had more symptoms at the end of the semester? Stress. They didn't do stuff on time. They didn't do stuff on time. What else?
Doing stuff on last minute.
Yes. Who's a procrastinator? I am.
Staying up late.
Staying up late, yes. That could definitely increase your stress. You're not getting enough sleep, right? So you're cranky. You're like that person from the Hershey's commercial. The Hershey's? Snickers.
Oh,
Yeah.
Snickers. Come with those Snickers.
Yeah, that's my husband sometimes. Okay, and then if you notice the non-procrastinators, who's a non-procrastinator? Raise your hand, be proud. I wish I could be like you. Okay. Good job. You're a non-procrastinator, I know that. So, if you notice, when the semester starts, they're a little stressed, right? So then, even though this stress continues to increase, it's still much lower at the end, right? Because maybe this person is only studying for the final exam, right? And that's it. No projects to turn in because they're done. This is how one of my daughters is, Korea. She finishes everything like a week ahead. And then I'm like up here, you know, trying to get my stuff done. The night before. Okay, not that it's good, but, you know, it just happens. So anyways, by week 6, they have about the same reported symptoms, right? So at that point, they have the same amount. Oh yeah, it was right here, approximately. And so that will be called the point of intersection. Now let's go ahead and start solving some of those problems. So first of all, for a system to have a solution, the point in question has to fit in both equations. So what I like to do is I like to number mine to number 1 and number 2. And so I'm going to test that point in equation number 1. So you will substitute your x value and also your y value. And you will keep the exact same thing for the rest of the equation. So it will be 4 plus 2 times 4. And we are testing to see if that is equal to 2. And so it will be 4 plus 8.
Wait, this is
Negative 1. Oh, true. So I need to substitute the correct number for y. Sorry. I didn't. It was not intended. 2 times negative 1. So that will be negative 2, correct?
Mm-hmm.
4 minus 2 equal to 2. And so 2 is equal to 2, so that is true. Now, it is true for equation number 1. Now, we have to test for equation number 2. So what we'll do that, so we'll take this equation, and x will be 4, and y will be negative 1, right? So this is a question, we're testing. So that will be 4 plus 2 is equal to 6. Is that true? Yes, it is true. So that means that the solution, and we can see the graphical representation here, it will be the point 4 comma negative 1. So that means that x will equal to 4, and then y will equal to negative 1. Now let's see, if we still had to test this other point, we already know it's not going to work, because this one is only intersecting at one point, and one point only. But if we check the other one, let's see how it will look. So it will be negative 4 plus 2 times 3. Is that equal to 2? So negative 4 plus 6 is equal to 2. So that will be yes, right? So this is true for the first equation, but if we take the second one, it will be this one. It will be negative 4 minus 2 times 3. Is that equal to 6? So here we will have negative 4 minus 6, and that is not equal to 6. So for a solution, for a point to be a solution, it must make a true statement if you test it in both equations. So it must be true for both. Okay, now we're gonna not test if a point is a solution, but we're actually gonna find the solution of a system by following the steps that we have here. So this method is called by substitution. And what we do is first we solve either of the equations for one variable. So we are going to solve for one variable in terms of the other. And then we're going to, if one is already solved in terms of the other, we skip the step, obviously. Now, step number 2, we substitute the expression found. So that expression found, we're going to substitute it into the other equation. And so while we do that, we're going to have only one equation, one variable. Then we solve that equation, the one that contains only one variable, and then we're going to back substitute into the other one. So here we're going to get numerical value or answer. Yeah, and then after that, that's where we're going to substitute back here to find the other value, the value of the remaining variable. Okay, and here, step 5 is to check your solution. If you have time, of course. So here, one thing that if it says by substitution, then step 1 is to select one variable that we want to solve for. So this is equation 1 and 2. So I'm going to say I'm going to solve for x in equation 2. So that will be from x minus 2y is equal to negative 3. I will have x is equal to positive 2y minus 3. So why did I choose to solve for x? So the coefficient is a 1. So that's the easiest thing. So now this is the expression that we found, and step 2, it says that we're going to substitute that into the other equation. So we're going to substitute that into equation 1. Because we started by solving for x in equation 2. So we take equation 1. Oh, I can't see. Which is 5x minus 4y is equal to 9. And in place of this x here, we're going to substitute that with 2y minus 3. And we're doing that because we want to end up with only one variable, so that will be 5 instead of x, 2y minus 3, and then minus 4y is equal to 9. Of course, here you have to use your algebra skills, so you're going to distribute the 5. So 10y minus 15 minus 4y is equal to 9. We're going to combine like terms. So 10y minus 4y, that will be 6y is equal to 9. And then this negative 15, if I take it across, from subtracting, it's going to go to adding. So 6y is equal to 24. And then we have to divide by 6. So y is equal to 4. Now that we have that, we're going to go back and back substitute. So we're going to the value, the y equals 4.
Yes, we have 4.
4. And here you could choose any equation. You could substitute it here or here. But the easiest thing is just to use this one, because it's already written in terms of x. So x is equal to 2y minus 3. So now we're going to substitute that number into the y variable. So that will turn into 2 times 4 minus 3, which will be 8 minus 3, and that is equal to 5. Oh, that was step 4. It's okay. So we could say our solution was x equals 5 and y is equal to 4. Our solution as an order pair will be 5, 4. If you have to write it as a solution set, it might be inside the braces or curly brackets. Okay, do we have a question? No? No question? Does anyone need to copy something? No? Okay, let's switch. All right, now we're going to go over addition method, and addition method is also known as elimination, because you want to use addition to eliminate one variable. And why do we want to eliminate one variable? So that we could solve one equation with one variable, and then we're going to back substitute again. So step number 1, if necessary, sometimes it's not necessary, you need to write your equations in this form, standard form. And sometimes it's not, but sometimes it will be necessary. You will have to multiply either equation or both by a constant, which is a non-zero constant, so that we can have the sum of the coefficients is 0. Either the sum of the y coefficients of this or the sum of x coefficients. So in other words, we want opposite coefficients. So the same number, opposite sign, positive, negative. So in this case, we're going to skip number 1 because they already, those equations are written in standard form. But we are going to have to multiply one of the equations. Step 3, you add the equations. Once you have opposite coefficients, you add them. You add the x with the x, the y with the y, the constant with the constant. So we will be adding vertically. And then we solve the equation for one variable. So here we're going to get a numerical value. Then we're going to back substitute the value to find the other. And then we check solution. Okay, so here we do have coefficients 3 and 9. So I have several options. I can multiply this one by negative, I'm sorry, not that one, the other one. Like let's say I want this 3x to be negative 9x. So what would I have to multiply that by? Negative 3. Very good. And I have that option. Or if I say, well, I want to eliminate the y's. Since I already have a positive 2 and a negative 8, I will have to by 4. Very good. Positive or negative 4? Positive, right? Because I already have opposite signs, so I don't want to mess that up. So I'm going to go that route. So when you multiply, you need to make sure you distribute that number. And if we do that, we will get 12x plus 8y. That will be equal to 192. And then on the bottom, equation number 2 will stay the same. So it's 9x minus 8y is equal to negative 24. Okay. Now we're going to, that was, so this was step number 2. And now we're going to do step number 3, add the equations. Correct. So we're going to add vertically. So here 12x plus 9x, that will be 21x. 8y minus 8y is 0y. And then 192 minus 24. What is that? 168. 68. Thank you. Okay, and then divide by 21. What do we get?
8.
8. Okay, perfect. I like when we get integers. I feel like it's correct. But however, you can still get a decimal
And a
fraction,
decimal will be okay.
an improper fraction. Not very likely, but you might. Okay, so now we finished step 3. Now we go back to, and we actually finished step 3 and 4, I guess.
Yay.
So now we'll go to step 5, back substitute. So we can pick any equation. Okay, that background music. So we could take equation 1 or 2. Or we could even pick the one after we multiply. It doesn't really matter. However, I like to stick to with the originals. So I'm going to take 3x plus 2y is equal to 48. And now I'm going to substitute the value for the numerical value for x, which is 8. And I'm going to solve for y. So 24 plus 2y equals 48. 2y is 48 minus 24. So 2y is 24. So y is 24 divided by 2, which is 12. Yes, do you write that 12?
Yes.
Okay, so I'm gonna let you guys work with your partner in solving example 4. So in this case, you actually have to rewrite them so that they're in this form, standard. So you're gonna have to manipulate some terms there. I'm gonna pause the video. We're going to check the answer for example 4, and in this case I'm going to multiply the first equation, 2x minus 7y is equal to negative 17. I'm going to try to cancel the y, so I'm going to multiply the first one by 5, because that is the coefficient that I have here. And then my second equation, which is 3x plus 5y is equal to 17, I'm going to multiply that by 7. And just positive 7 because we already have opposite signs here, so I don't want to change that. And once we multiply, we're going to obtain the new system, or well, it's the same system, but the new equation. 10x minus 35y is equal to negative 85. And then 21x plus 35y is equal to what? Positive 119. Thank you.
Wait, negative 85? Come on.
Yeah, because this one is negative, right?
Well,
It will be 50 plus 35, yeah. 85.
what did you do?
Okay, then that will be 0y.
Why
So,
is it a negative 80? Wait.
oh, because here, is this negative or positive?
It's negative.
Okay, so this negative from here is here. So we didn't move the numerical term on equation 1, so it's still negative.
Oh, you didn't move the 2 or the 17, you just moved the
Correct.
7.
They stayed there.
I
They're
did
right.
the other thing and moved them both.
So here we get 31x. And can someone
31.
do it?
That's what I did.
34.
34.
Yes.
Okay, so then x will be 34 over 31. That's right. Okay, now let's find y. So I'm going to take equation number 2, which is 5y is equal to 17 minus 3x. And I'm just going to substitute the numerical value that I got for x. So that is 17 minus 3 times 34 over 31. So 5y is equal to 17. Remember here when you multiply fractions, it's just straight across. So 3 times 34, that will be, well, negative 3. That will be negative 102. Thank you. And over 31. Okay, so here we know we have a denominator of 1. So we needed to have a 31, right? So we can only get that by multiplying top and bottom by 31. So if we do that, does anyone multiply 31 times 17?
It's 527.
Thank you. 527. So then 5y is equal to, and then can someone subtract 527 minus 102?
It's 425.
425 over 31. Can you see if that's divisible by 31?
Yes, ma'am.
What is it?
It is not.
Okay, so that's fine. So 5y is equal to 425 divided by 31. Now, the 5 is multiplying to the y, correct? So if we divide by 5, we could do the following. 31 and then 5.
Right.
So that 5 moves to the right from multiplying is going to be divided.
It's 31 times 5 is 155, and then 425 divided by 155 is it's a decimal. It's not a good number.
Okay, well then we could just reduce it. They're both divisible by 5, right?
Alright.
85 or
531.
And that's okay. You could have an improper fraction. Now, when you enter your answers on my math lab, you need to be careful and see if they want a fraction. A fraction will be the exact answer. And a decimal approximation, that will be an approximation. Okay, so systems of equations, we can divide them into two. We have consistent and inconsistent. And so, oops, I did it backwards.
Oh no.
So that should be consistent. And that should be inconsistent. Okay, and so inconsistent, they will have no solution. And graphical representation, you will have parallel lines. They do not intersect. Consistent, you could have either one solution, but we call those independent. So those have one solution. And the other type, they are dependent. And they have infinitely many solutions because they are the same line and they are overlapping. You can see a little bit of the color here. I have like the red line and the blue line overlapping. Well, each other, one on top of the other. So we could also say the lines coincide. Independent, exactly one solution, 1 point, like the one we were solving. Okay, so let's see how a system with no solution will look like. You can see here, no solution. So we see they're both already written in terms of, in standard form, right? So we could choose to use to do addition. So I'm going to multiply. So I'm going to multiply the first equation, 4x plus 6y equals 12. I'm going to multiply that by 6. And my second equation, which is 6x plus 9y is equal to 12. I'm going to multiply that by negative 4. So why negative 4? Because I want to match this coefficient, right? But in negative because I want them to have opposite signs. So after we multiply, we will end up with 24x plus 36y is equal to 60 plus 72. Thanks. And then the second equation, it will be negative 24x minus 36y, and that will be equal to negative 48. So let's see what's going to happen here. The x's have opposite coefficients. The y's have opposite coefficients. And so we can see that we will have 0 on the left. But on the right, we're going to have a number. What is that number? 24. So you know that 0 does not equal 24. So when you get a statement like that, like 0 equals a number, you know it's false. So that's how you know there is no solution. And graphically, they look like two parallel lines. That's another way you could check. Okay, now the system number 6. We're gonna solve it, and this one has infinitely many solutions, so let's see how that will look like. This one I'm gonna solve it by substitution because I already have an expression for y. So I'm gonna substitute in equation 2. I'm gonna substitute y with the expression 3x minus 2. So we'll take the second equation, and we're going to substitute y with 3x minus 2, and that is equal to 10. So then we need to distribute here the negative 5. That will be negative 15x minus, no, not minus, plus 10. Remember, negative times negative, so that will be positive. And so here you could see 15x minus 15x is 0. So now we have 10 is equal to 10. And that is always true. So what you get here, this is called an identity. And so this one will have infinitely many solutions, but those solutions have to still satisfy both equations. So it's not going to be, I'm going to graph one of them, so by using I can find the y-intercept and then use the slope, which is 3. 3 up, 1 to the right, 3 up, 1 to the right. And then I can connect that. And since I know that I'm going to have infinitely many solutions, I can assume or infer that the other equation is going to be right on top of this one. So any point that is on this line will be a solution. So for example, one solution will be 1, 1. Another solution, it will be 2, 4. And then we have an infinite amount of points because you have an infinite amount of points on any line. However, if I say, is this a solution, this point out here?
No.
No. Okay? So it's not everything, it's like, yeah, a lot of them,
No line.
but not whatever, you have to be on the line, exactly.
So what's the slope?
Also with what? 3.
3 and then what? It's raised to 1.
3 over 1, right. So 3 up, 1 to the right. Okay, we're going to pause here so you can go take a break, and then we'll continue when you come back. So the solution, infinitely many solutions, but they all have to be on the line. Now we have a mixture problem, and we have a chemist working on a flu vaccine, needs a mix of 10% sodium iodine solution with a 60% sodium iodine solution. So we have a 10% concentration, 60% concentration. And he needs to mix those two to obtain 15 milliliters. So we don't know if it's 25 milliliters from one, 25 from the other. But what we know is that they want to have a 30% concentration coming from the mixture. So we have here the first one with the low strength, 10% of sodium iodine. We have the 60% solution here. And we want to have something kind of like in the middle, but not really, right? What is the difference? In the middle will be what, like 20%, right? If you add 10 plus 60. Oh no, actually, if you get the difference, what is in between? 60 minus 10? 50? So then it will be like a 25. A 25 will be right in between. So they want it a little stronger than half of those. So we cannot just pour half of one, half of the other. So what we're going to do, so this will be the solution with the 10%. This will be the solution with the 60%. And this will be the solution with the 30%. So here, our variables, if you look at the question says how many milliliters of the blah, 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 blah. So the variables are actually going to be X and Y will be representing the number of milliliters. Not the concentration, but the number of milliliters. And we know that the full one, we want it to be both of those, right? X plus Y. Okay, now the percent of the sodium iodine, here we have 10%, which we're going to use 0.1. Here we have 60%, so we will be using 0.6 or 0.16. This would be 0.10 if you want. And here for 30%, we will be using 0.30. Okay, so now if we multiply this number here times the number of milliliters, we will get the amount of sodium iodine, the concentration. So this will be 0.10x, 0.60y, and the last one will be 0.30 parentheses x plus y. So now from that table, oh, and actually we do have a number for the x plus y. Where do we know that? Combined, what has to be the total liquid in milliliters?
50.
50, right? So I guess we could just replace that with 50. And so if I do that, this will be 0.30 times 50, which will equal to what?
15.
15, right? Yeah, 15. So what does this tell me? This
X and Y must add up to 15.
well, the both liquids combined for 50, but what do you say about the 15?
X and Y themselves must add to 15. Well,
No, x and y is 50. So x and y is
that's then multiplied, right?
all the solution with the sodium iodine, and what do you guys think is the rest? So if I tell you you have a sodium iodine solution of 10%, you have 10% of sodium, what is the symbol for sodium iodine? NaI? I don't know about the, okay. Let's just say sodium iodine. So what is the rest? What is the other 90%? What is it? Is it oil?
Not
It's water. Water. Maybe saline water. So here, can I get your attention, please? So here we have sodium iodine. Plus water. Combined is 50 milliliters. But right here, this 15 milliliters, what is that going to be? Only sodium iodine. And it will have a concentration of 30%. Okay, so now from here, we're going to make two equations. We need two because we have two unknown variables. So one of those is going to refer to the total liquid. And that's the one we were talking about. So x plus y equals 50. The total liquid of everything. Water plus sodium iodine. And the other one will be referring to the concentration. So if we add 0.1x plus 0.6y, we will get 15. And then from here, we solve the system. We could use, I'm going to use substitution. So I'm going to say x plus y equals 50. I'm going to choose to solve for x. So x will be 50 minus y. And then I'm going to substitute into the other equation here. So it will be 0.1 times x. So instead of x, I'm going to use 50 minus y. Plus 0.6y is equal to 15. So then I'm going to distribute this. So this will be 0.5. Is it 0.5? No, it's 5. So we'll have 5 minus 0.1y plus 0.6y is equal to 15. I'm going to combine like terms here. So 0.6y minus 0.1y will be 0.5y. And here I have positive 15 on the right side. I have a positive 5 that if I take it across is going to be a minus 5. So that would be 10.5y. So then y will be 10 divided by 0.5. 20. Thank you. And then now that we have one of the numerical values, we know that if y is equal to 20, then x is going to be 50 coming from here minus 20. So x will be 30. So what does that tell me? Well, x was representing the number of milliliters of the weak solution. So we need, what was x? Forgot, 30. So we're going to need 30 milliliters from here, and we're going to need 20 milliliters from here. And that's the end of that problem. Do you guys need time to copy it? The bottom maybe? Okay, so I'll give you a few seconds. Okay, now the very last one is talking about air resistance, right? Well, kind of. A trip on a, what is it? A small airplane. So we have when a small airplane flies with the wind, it can travel 450 miles in 3 hours. So with the wind. And then when the same airplane flies in the opposite direction against the wind, it takes 5 hours to fly the same distance. So you could see 2 hours more if it is against the wind, right? So the question here would be, find the average velocity of the plane in still air and the average velocity of the wind. Okay, so we're gonna use for the trip with the wind, we're gonna use x plus y. And against the wind, x minus y. So we will consider x to be the velocity of the plane's velocity. And then y will be the wind. So here they're acting one against the other, so that's why we have x minus y. If it's with the wind, we combine both. Now for time, we have that with the wind, it takes 3 hours. Against the wind, it will be 5 hours. And the distance for both is the same. The distance is 450 miles. And remember here we're multiplying. Okay, so we're gonna go ahead and distribute. So the 3 will multiply 3x plus y, so we will get 3x. Well, let me write it this way first. Then 5 times x minus y equals 450. Okay, so from here we'll get 3x plus 3y. In this case, I don't want to distribute the 3 all to the right side, only to the left. And that is equal to 450. So we'll have 5x minus 5y is equal to 450. And so to solve it, you guys can see we have opposite coefficients here already. So we could just say we're going to multiply the top equation by 5 and the bottom one by 3. So by doing that, we'll get 15x plus 15y is equal to something. Can someone get this? Or someone with a calculator? And the other one will be 15x.
It's 2,250.
Thank you. Okay, and then the other one, 3 times 450.
It's 1,300.
Okay. So we solve it, and the y will equal to 0. So we have 30x is equal to 3,600.
Yes.
So then x will be equal to 3,600 divided by 30. 120?
Yes.
Okay. So then x will be 120 miles per hour because we're the units. And then for y, you could substitute x into any of them and then figure out y. So I'm going to substitute it in here. 3x plus 3y is equal to 450. So we substitute 3 times 120 plus 3y is equal to 450. So that will be 316 plus 3y is equal to 450. So positive 3y is 450 minus 360. What would that be? 90?
Yes.
Okay. And so then y is equal to 90 divided by 3, which is 30. So then y, which is the wind, will be 30 miles per hour. Now, if the questions still error and was available, yeah. So it will just be x and y. So I forgot there was one more. I thought the other one was the last one. Okay, so the break-even analysis. Okay, so we have 3 things here, very common. So we have cost, of course, which is like how much it costs for you to produce an item, right? So the cost is fixed cost. For example, how much you pay for the to rent the place. Where the units are made, or to pay the employees no matter how many units are made. So that's fixed cost. Now the cost per unit could be like the materials of that unit. And to find the cost function, you have to add them both. And of course, how many units do you have? You use a variable. Now the revenue. So this is money going out. And then the revenue is money coming in. So it's like how much you sell a unit for. Right? But if you have been involved with fundraisers, for example, you know that the revenue is not all the money you get to keep, right? Because you still have to deduct what? The cost. So this is what we call profit. So profit is equal to the revenue, the money you earn after selling your items, minus how much you pay for it, which is the cost. So profit is what you actually make. So the only time that you will break even is when the profit is equal to 0. So this is when you break even. And if you break even when the profit is equal to 0, that also means that the revenue, if I take this negative C of x to the left, it will be that the revenue is equal to the cost. That's what it means to break even. Okay, so here to find a break-even point, we have technologies now promising to bring life, fast, and beautiful wheelchairs to millions of people with disabilities. I hear a lot of people talking, just talking. So, companies planning to manufacture this radically different wheelchairs. Fixed cost will be 500,000. Okay, and it will cost 400 to produce each. So that will be the cost per unit. So let's write the cost function. So C of x will equal the fixed cost, which is 500,000, plus the cost per unit, which is 400 per unit. That's cost. Now, revenue function coming from here, they will be sold for 600. So 600 per unit. Now determine the break-even point. So remember, to find the break-even, one will equal the other. So we could say the cost will equal the revenue. And that will be, well, it was 500,000, right? Okay. Okay, so here what I can do is take the 400x to the right side, or subtract 400x. So that would be 600x minus 400x. That would give me 200x and so then x will be that divided by 200. $2,500? Yes? So, and what was x? Number of units. Very good. In this case, the wheelchairs. Okay, so that's the end of this one.